Hello all, welcome to learning structural steel fabrication modeling in Autodesk Revit, and it's very essential to choose the proper template before you start modeling any architecture, structure or MEP model in Revit, so that you do not have to again and again load the respective family. So in architecture template, all the architecture families are loaded up. In the structural template, all the structural frame families such as beams, columns, framing, bracing, everything will be available with us. And in MEP template, all the MEP components will be available with us. So now, without further talking much more about other thing, let me start how to do the structural steel fabrication modeling in Autodesk Revit. And for your ease, I have also prepared notes. So I will be giving you the notes, and these are the notes that we will be follow and how to use the proper these notes. I will be explain each and every steps one by one. So first is, as we know, before we start working on any one of the project, it's essential to create the levels, grids, levels and grids, and thereafter we can place the columns on that grids. Okay, so we have opened up the Revit. Now click on new, click on browse, and here we will choose English Imperial is use the template for feet and inches, and English is used for the metric. So we will use the English, and here there is an option of structural analysis default metric. So we will go with this structure analysis default metric. Click on open and click on OK. So our template has been loaded. Let me save the file first. Let's say steel modeling, and go to option and click on number of backup 1. OK, save. So our model is now going to be saved. What is our first step? Change unit to centimeter. So we will go to the manage. Here there is an option of project units, or you can type alternatively UN. So let me type UN, and from the units we need to change its units from millimeter to the centimeter. So what I will do, I will be type UN, and here there is an option of length, and click on the unit, and here I want to change to the centimeter. Okay, okay. Let me save the model first. Then after, what is our next step? Our next step is we need to create the level. Now for your ease of creation of modeling, I have created or work only with the 3 levels, but obviously as per your project requirement, you can create as many levels as per your requirement. So I have created the 3 levels, and the distance between 2 levels is 5 meter. So this is 0, this is 500 centimeter, this is 1000 centimeter. So to create the level, we will go to the south elevation. This is 300. Let me rename to 300 to 500. So level 2 is 500 and level 3 is 1000. So what you can do, double L, you can specify any starting point, any ending point, and then after you can directly change its height to the 1000. Now it's necessary, this sentence, read this sentence. It's necessary to create the level first, and then after you need to create the grid. So that what is happen, whatever the grids that you are creating, either in level 1 view or level 2 view, it will be visible in all the view. What I mean by that, let's say right now I have created 3 levels, level 1, level 2, level 3. And if I will be create the grid, so extents of the grid will be up to level 3. In future, if I will be add 2 more levels, let's say level 4, level 5. So those grid will not be available in level 4, level 5. So if your levels are already decided in starting phase of the project, it's necessary and crucial to create the level first, and then after you need to create the grid. In our example, we will be stick with the 3 levels. So 3 levels we have created. Now we will go to the level 1 plan view, and we will create the grid 700 by 700 centimeter, and we have 3 grid vertical and 1 2 3 4 5 grid horizontal. So what I will do, I will be use shortcut of grid gr. This is grid number 1, and copy, make sure multiple and constraints should be on, and I will be create 5 random grid and use the dimension shortcut di. This is my starting point, second point, third point, fourth, fifth, and click outside. Turn on the equality, and the distance between level 1 and level 2 is 700, so that all the grid can have the 700 distance. Now here you can see due to some instances only EQ is displayed. So let me change from EQ to the value. So now as you can see 700, 700, 700, 700. Similarly, GR, this is my starting location. Now here I want to change from grid number 6 to caps A, and let me make a copy to DI, starting point, ending point, and let me turn it on equality and change equality display to the value, so that it will be display the value. Right now as you can see the distance is 595. We are not satisfied with that distance. Select the grid number B and let me change to the 700. So now as you can see 700 distance is also maintained on the other side of the grid. Now let me save the project. So our step number 6 is done, that we have created 3 vertical grid, 5 horizontal grid, and spacing between the grid is 700 by 700. Obviously this is for the project purpose showing example. I have created the levels as per my requirement with the spacing. You can create as per your requirement. Our main concern is we have to understand the workflow, and we have to understand the command which are readily available within the Revit to do the structural steel modeling in depth. Now we will be place, our next step is to place the structural column. So what we will do, we will go to the steel tab, and here there are command related fabrication element, modifiers, parametric code, and in the structure tab here there are command available related to modeling the structure. So let me start from the structure, and here we will use structural column tool, and we will use universal column. UC means universal column, and let's say we will use 305 by 305 by 97, and we will be use the column instead of depth to height, and we will be used from level 1 to level 3, and we will use the space bar because orientation of column we want to use like this, and we will select all the grid. Now read here, use at grid intersection tool and select all the grid except B. So what I will be do, at all grid intersection select all the grid and shift and press deselect the grid number B. So on the grid number B my column will not be placed. Now before clicking on finish, here you can see my orientation of column is not proper. So first I will be use the space bar. As you can see my orientation column has been changed to all of the column to the exact location or exact orientation, as you can see whichever you want, and then after you have to click on finish. So otherwise you have to select the column and make it individually to change the orientation. That we do not want to do, so that's why we have first set the orientation as per our requirement, and then after we have finished the command. Now we need to change, as you can see this is just display as a line shape, so we need to set the detail level to 5 and use the wireframe, and thin line we can on off. So as you can see, if the thin line is on, our column is displayed like this, so we will turn off the thin line and let me save the project. So our first chapter is now completed, in which we did we have seen how to create the levels, how to create the grids, and how to place the columns. Now our next step is we need to create a beam, and our first step is we need to create an inclined rafter beam. So rafter beam obviously we will be create in the elevation view. So we will go to the south elevation view. Now in the south elevation view, what we will do, we will use the beam command. So here there is an option of structural framing or beam, shortcut is BM. And now it is asking, because south elevation, on which phase you want to do the modeling, right? So use the beam command and we have to set the we have to draw on the grid number 1. So on the grid number 1 we want to draw the inclined member, or we can say after, and then after on the 15 degree we can draw. So this is my starting point, and at a 15 degree I can click at here. So as you can see, this is the one inclined member that we have drawn. Here also we can set a detail level to fine and set it to wireframe, so it will be display everything. Now do the mirror on opposite side. So finally it will be have a like this view. So selecting this, here there are two mirror command, one is peak axis and one is draw axis. If you do not have any reference, you can use the draw axis. If you have the reference, you have to click on peak axis and selecting this. So as you can see, it is automatically cleaned up this joint, and we need this mirror this inclined member. Now select both beams and go to level 3 view, and we need to copy all the way to the vertical side. So what we can do, we can selecting both this beam, inclined beam, by using the control key. First let me show you in 3D view how it looked like. So as you can see, on the grid number 1 we have drawn the inclined member. Right now in 3D view it is not displayed properly. So let me have a detail level to find and visual style to shade it, and let me save the view, save the project. As you can see, now what we want to do, we want to go to the south elevation and selecting both inclined beam, go to level 3 plan view, okay, because that is our top plan view, and let me make it to copy multiple and constraint on, and let me do the copy from grid 1 to grid 2, 3, 4 and last that is 5, and go to 3D view. As you can see, each and every joints are very nicely cleaned up, and we have created one structural steel framing, right? So in the 3D view, level 3 view, we have to set a detail level to 5. If we are not able to see, here you can say we are able to see only the member in form of the line. So we need to set a detail level to 5 so that it will be display all the members. Now that is a view range visibility in the level 3 view. That's why from this above view the members are not showing up. But if you wish to have properly see, you can go to the side plan view, because side plan view doesn't have any limitation. So you can go to side plan view and you can see entire structure from your base to the top. Okay, good. Now next thing is what we want to do. We want to use the beam system tool. Now what is a beam system tool? First, beam system tool is nothing but to load or to create some sort of beams family, right? Beam to draw or model some beam. So what you can do, first you can use the beam command and you can load whichever the family which you want to use as a beam system family. So beam system family is nothing but the combination of multiple beams. So rather than doing the modeling of each and every individual beam, you can use the beam system tool and you can do the modeling of that beam. But before start modeling of the beams using the beam system, it's necessary to loaded that family. So our first step is we load the beam families or structural framing families. So we can go to the structure tab, beam, load family, and we will go to the English, and then after structural framing, steel beam, universal universal beam, AISC, This is our universal beam, and let me click on open. And what is the type? 178 by 102 by 90. So we can go to the all the way to the downside. 178 102 19. This is the for example purpose I have created one section size, chosen one section size, but you can choose as per your requirement. Now we will be use the beam system tool, and we will be use the set work plane to this inclined face of the beam. So what we will do, we will go to the 3D view first, and then after, let me save the project first, Control S. Now here there is an option of beam system, and in the beam system we will be use set pick up plane, so that on which face you want to draw the beam. So we want to draw the beam system on this inclined face. So we will click here this inclined face of the beam. Okay, and then after we will go to side plan view, change detail level to fine. So in side plan view, let's say set detail level to fine, and you can change the property of the beam system as per your requirement. So let's say fixed distance, let's say 160 centimeter. We want to keep the distance, and what is the section size that we want to keep? That is universal beam 178 102 by 19 universal beam that we have just loaded up. And then after we can create the shape. So what you can do, you can use the rectangle shape, and you can pick this intersection going all the way to the down, and pick this intersection. We have already set the inclined face. Just go to finish the tool and go to 3D view, as you can see, and beam direction tool. So let me do the undo once again, and going to the side plan view. Here there is by default beam direction is horizontal, but let me use beam direction and pick this. So now my beams will be pick or draw on the vertical side. So let me go finish the command. As you can see, my beam direction is set to vertical, and now we will use the finish. In the side plan view, we have to do the mirror. So what you can do, you have to select the entire system. As you can see, if I'm just moving the mouse, hover over this beam system, my entire beam system is now selected. Don't select individual beam. Now use the double M mirror, and we will do the mirror. As you can see, such type of inclined beam now we can create by using the beam system tool. Obviously later on we will be also apply some connection here and everything is mentioned in this PDF step by step. So we will do this step by step. Now we will complete this beam system. So what we will do, we will select this beam system and use the control key and selecting this beam system. But this time, rather than doing the copy, let me do the array, and let me keep last, let's say from here to all the way up to here, and number of items, let's say 4. So as you can see, 1 2 3, and original one is 4, and going to 3D view. So as you can see, my structure is now ready with inclined members as well. Now we will be create the second floor construction level at one side between the grid number 4 and 5, and all our other levels are mezzanine level. Okay, and here it is between, as you can see, this is from level 1 to level 3, but here on the between grid 4 and 5 we will be create second floor levels construction as well. So going to level 2 and set the detail level to the fine. Okay, and then after, what we can do, create the beam between grid number create the beam as shown below. So we will use the beam, use the same type 178 102 19, and we will be placed at the level 2, and then after we will be specify starting point here, ending point here. It will be automatically joined. Similarly, repeat the same steps at here. Okay, and lastly we will create one beam vertical here as well. From this midpoint to this midpoint, it will be automatically trim and join. So if you will see the 3D view, as we can see such type of one structure, intermediate level of beam at level 2 we have created. Let me save the project. Now we will use the beam system with the same properties, and we will create the beam system horizontally. So what we will do, we will be going to the level 2 plan view and use the beam system tool, and then after we will be use the sketch beam system and draw the rectangle shape, let's say from here to all the way up to this side. Make the beam system horizontal with the property 160 center to center, and universal beam 178 102 90 smaller section, just finish. And we will do the mirror on the opposite side. So if you will see in 3D view, such type of one system, beam system we have created. Now next step is going to level 1 view, select any one of the column, use the create similar, and use the change height to level 2 and place at here and here. Okay, so we will going to level 1 view, use the structural column, or you can select in this column, right click, create similar. So same this property will be applicable, but instead of level 1 to level 3 we will use level 1 to level 2 and use the space bar. Click on this intersection and click on this intersection, and if you will see in 3D view, as you can see, it has been now placed one column here as well. Good. So far what we did, we have placed the structural column, we have placed the principal inclined after, then after we have also placed the beams, then after model the beam at level 2 view and model the column between level 1 to level 2. Good. Now it's time to start do the modeling of the brace command. So now we will be use the brace. Obviously, if you have loaded any one of the beam family, it will be applicable to beam as well as brace as well as beam system and as well as truss. So any one of the structural framing family will be applicable to either any one of these 4 commands, either beam or truss or brace or beam system. So what we can do, we will be use the brace BR and we will be load this family. L angle section we want to use as a brace system, and this is the section size 127 89 9.5. So what we will do, we will be use the brace command but load family and metric L angle section. As you can see, metric L angle section, you can go into the English folder, structural framing, steel, and then you can use this angle section, and then after 127 by 89. So we will going to like this 127 89 by 9.5. Obviously you can use any one of the section size. Now we will go into the east elevation view and we will be do the modeling on the grid number C. So we will be do the modeling of bracing on this grid, that is our grid number C. So we will going to the east elevation view and we will be use the bracing command and we will do the modeling on grid number C and click OK. Okay, and we will be create the grid, create the brace like this. So we will keep some distance at here and start modeling of bracing. So this is the one inclined brace we will be do the modeling, and by using the draw mirror tool DM, because here we don't have any reference, so we will use the draw mirror, pick this point, pick the vertical, and it will be drawing this another inclined beam as well. Now we will be going to the 3D view, select highlighted brace. This is the one highlighted brace that we want to select and change its property. So Y justification we will be set to the right. Now what is this? Let me explain you. Going to 3D view. As you can see in the 3D view, this bracing is not going to be placed properly. So we will be selecting this bracing and we will be change y justification to the right. So as we can see, now my brace has been set to the proper location. So first change its orientation to 180 degree and y justification to the left. So let we use angle orientation 180 degree, and rather than right, left, and selecting this and this one we will be used as a right side. So as you can see, these two bracings are now completely meeting right at the proper face. Select other brace and change justification to the right. So as you can see, this one is on the left side and this one is on the right side. Y justification, that we need to change it out. Good. Now select both bracing and going to level 1 view and do the mirror opposite side. So this is the one bracing that we want to do the mirror. So what we want to do, we will select this both bracing, selecting this by using the control key and going to level 1 view, and this is the bracing and and pick this grid B, going to 3D view. As you can see, now here we also have to make sure my bracing is going to be placed with correct orientation, with correct rotation and correct justification. Good. So till now we got a satisfactory result, that exactly what we want. Now our next step is to place the foundation. So going to level 1 view and we will be use the isolated foundation 1800 by 1200 by 450. This is the one standard foundation type that we want to use. If you want to create another foundation site, obviously you can go for it, and we have to just follow the procedure. The point of important of understanding is you need to understand the procedure and workflow. It's not necessary that each and every step you can exactly follow that what am I doing. But yes, if you will be follow exactly each and every step that what am I doing, then you will be definitely able to complete the one project after completion of this, right? And this is the one type, and we will be used at all grid intersection, and we will select all the grid except B. So at grid intersection, select all the grid and press the shift and deselect the grid number B, and let me finish it. And going to 3D view, as you can see, we have placed the structural foundation as well. Good. Now it's very important starting the connection. So now we will be see how to use the connection. So if I will be going to structure, here there is an icon of connection setting, and by default here you can see there are some connections which are readily available with Autodesk Revit installation. So we will select all the connection and we will click on add. So as you can see, all of the available connection is now loaded into the loaded connection, and we will simply click on OK. And you have to wait for some time in order to load all the connection and immediately save the project. Good. Now we have loaded all of the connection. Now select the bracing and column. This is the inclined bracing. This is the inclined member and column. Okay, and we will be use the connection tool. So what is written? Use the connection tool. So what we have to do? We have to apply one connection at here. So this is my inclined beam and this is my column. So I will be going to the steel tab connection, selecting inclined beam, selecting the column and press the enter. So as you can see, one generic connection. By default it will be comes up with the generic connection. Okay, so one generic connection is now available with us, and here it is important, what is this and what is this. This is 2 means this is the secondary member, and this full dot with larger diameter is the primary member, and obviously we want to make this column as a primary member and this one we want to make as a secondary member. So as you can see, I have also mentioned it here. Dot 2 dot with 2 number circle indicates a secondary member, and other dot indicates a primary member. You can also click on second number dot, and you can make this dot as a secondary and this dot as a primary. But I want to make this member as a primary, column as a primary, and this one is a secondary. So I will be make a number 2 at here, right? You can change the connection type from generic to knee of frame bolted. So I will be use knee, search knee of frame bolted with punch. So as you can see, set detail level to fine. Earlier the error was come because your detail level was not set to fine. So all these connections are visible only in the fine detail level. As we can see, we have applied very nice connection at here. Good. Then after we will be now onwards we will be use the millimeter system of unit, because we will be see each and every in-depth option related to the connection. So we will be use the millimeter system of unit. So we will be type UN in the length, change to the unit to the millimeter. Okay, and let me save the project. Good. Now we have to select the connection, and we can change the there are many options available with this connection. Okay, so you can select the connection, and so you can select this connection, and if you want to break this connection, the connection will be break, so that each and every member is now available as an individual member. So let me do the Control Z, and you can also customize as per your requirement, and then after you can make the modification. Let's say increase the plate size, removing this plate, and so on, right? Now choosing the right connection. So what you can do, you can select a column, select the brace, and use the connection tool. Now what we can do, select the column, select this bracing. So first we will use the connection, select the column first, bracing second, and press the enter. Now as you can see, column is the primary member and bracing is the secondary member. And now we will be loaded. We have already loaded all the connection, so this step we do not want to be performed because this is now already available with us. And next, and change its type to the end plate with bolt. So let me change end plate with bolt, so that it will be applicable proper bolted connection. As you can see, this is the proper connection. Here you can see we can see the many more connection, but it's essential which one connection will be applicable where. And later on I will also show you how to make our own custom connection, and we will be create a custom connection for this base plate with the foundation and anchor board, foundation and column, and we will be applicable those connection to the at all the places. Good. Now here you can see this is our main connection, right? And this symbol is the weld symbol. So as you can see, there are some weld symbols are also there, welding between bracing member and the column member, right? So let me save the project first. Then after what we will do now, we will see how to use the bolt tool. So go to 3D view, and this is already we are already in 3D view, and now we want to create the bolt at here. So here there is a command of bolts. Okay, and now select both the bracing using the control key. So using the control key I am selecting both the bracing and press the enter. Okay, and now select the highlighted face where you want to place the bolt. So I want to place the bolt, let's say on this face. Good. And now go to right side view, and in this intersection This is the intersection where I want to create the bolt. So let me create a one circular shape, diameter let's say 25, finish, diameter let's say 20. So you can also make a detailed line and you can find the exact center. I already picked nearby to the exit center. As you can see, this is the one bolt exactly what we have used. But right now right now there are three bolts. But I want to use instead of three to one bolt, and then after changing the diameter, let's say 24 mm diameter. So as you can just select the bolt, change the diameter to 24 mm, number to one, and coating. If you want to apply, you can also apply the coating. Let's say stainless steel bolt A2 coating, and you can go into the east elevation view, okay, and set the detail level to the fine and wireframe. And now you can use the detail line command dl. This is the one and this is the other, and now you can selecting this bolt and you can use the arrow key, or you can click and drag, and you can also move to the exact location, okay, like this. So center of this the intersection of this detail line and this bolt is now exactly matching up, as you can see. Remove all the detail line, okay. Now let us we want to go for the apex connection. So go to 3D view, zoom at the apex connection location. So this is my apex connection location, and we will be used the shorten tool. So if I will be going to 3D view, obviously you can also copy paste this bolt to the opposite side, mirror, you can also do. Now here you can see there is a little bit problem at here. This beam is not properly joined. So what you can do, you can use the shorten tool and selecting this beam. So as you can see, the beam is now going to be shorter, okay. And then after change to the length, let's say 8 mm. So let me change to the length 8 mm. Good. And change the angle to the minus 15 degree along the height. Let's say minus. Why minus 15? Because our members are going to place at minus 15 degree. 15 degree. Okay. Now repeat the same procedure for the opposite side of the inclined beam. So what I can do? Shorten. Selecting this and selecting the shorten modifier. Change length to the 8 and angle will be 15 minus 15. As you can see, inclined member is now going to be created. Now we will be going to the east elevation view. So go to the east elevation view, change the visual style to wireframe. So going to the east elevation view, and let me change visual style to the detail level fine and visual style to the wireframe. Let me save the project. Now we will be use the set tool, and we want to draw at grid intersection B. So let me use the set pickup plane, or let me use the set work plane grid intersection B. So whatever we will be draw on the television, it will be draw on the grid number B. Good. And use the plate tool. So here there is a one more command we are going to use, that is plate tool, and we will be create the plate, okay. So this is my east elevation, and we will be create the plate at this location. So let me use the rectangle shape, and we will be use create the plate, and let me just finish the tool, and let me see in the 3D view how it is look like. So as you can see, this is the one plate that we have created, and from the property change thickness to let's say 15.5 mm. Now that's why we have changed the unit to the millimeter, so that each and every units now we are following to the millimeter. And going to the side plan view, and let me move this plate to the exact location, right? So let me move from this point to the exact at grid B. So as you can see in the 3D view, now it is exactly in the center. So here you can see we will be use this plate connection as well. Now here we will be placing some bolts as well. So we will be use set peak plane first. Let me save the project. Set up plane or pick up plane. Pick this front face. Okay. Sorry. Set pick up plane. Pick this face because we want to create another plate at here on this face of this inclined member beam. So as you can see, use set tool and pick face as shown below. So we want to pick this face. Now we will be create the shape of the plate, and we will set a detail level to the fine. So what we can do, we can go into the south elevation as well, or we can directly click on this front view, and then after use the plate tool, use the rectangle shape. Now we will draw the one line at here, and what we will do, we will be draw the incline, snap to the midpoint and incline one member here. Now from this 100 up, 100 down. So we will selecting this 100 up and we will selecting this 100 down. Okay, and then after we will trim these two member, and then after we need to fix this distance, right? So this distance is 140 mm. So we will pick this point. Let's say 140 mm. And now let me finish. As you can see, one plate is now going to be model. So select the plate and change thickness to the 10 mm. It's already 10 mm. Now use the weld tool. Now let me see how to use the weld. So what we can do, use the weld tool. Now it's necessary where you want to do the weld. So it is asking select the element first, second, and then after you need to specify weld of line. So what you can do, use the weld tool. This is my first member, this is my second member, and press the enter, and it is asking the intersection face of the weld line. So this is my intersection face of the weld line. So as you can see, my weld symbol is now available. So this is how you can apply the weld. Again, let me show you once again. Control Z. So first you need to do the weld command. Select the element by using the control key. Press the enter and select the intersection line. So your weld symbol is applicable. Select the weld, and from properties we can change its size. As you can see, select this weld, and from this property we can change fillet weld. There are many type of welds are available at here, and thickness of the weld, that is 6 mm. And select the weld, go to side plan view, change visual view style to wireframe, and do mirror in remaining three. Select weld and plate. So let me do selecting the weld and selecting this plate, going to side plan view, fine, wireframe. Let me go into 3D view, selecting the weld, selecting the plate, going to side plan view. As you can see, this is the one side. Now let me do the mirror. So mirror, draw a peak axis. Let me peak here. Grid number this middle grid. Then after going to 3D view, these two are already selected using the control key. Again selecting these two, so total is now 4. Going to side plan view and mirror, peak axis, and selecting this inner member. So now as you can see, it has been now model all the 4 sides, as you can see. Now what we want to do, next step is we want to use the bolt command. So what you have to do, bolt. It is asking from where to where you want to do the bolting. So we want to do the bolting from this plate. Use the shift key and middle mouse button, orbit to the opposite side, use the control key, selecting this opposite side of the face. So I want to draw the bolt or create the bolt touching these two face, and then after press the enter. Okay, and it is asking on which face you want to create the bolt. So I will be selecting this front face. Make sure this option should be turned on, select element by face, so that it will be easy to selecting this. Good. And then after I will be going to the south elevation, and you can create the shape. So I can create the shape like this. And what you can do, you can select all these things and you can rotate by the 15 degree, because our model is inclined at 15 degree, and more or less you can maintain this shape. Good. And then after finishing, now select the bolt, and from the property we can change its diameter. Let's say we want to use 24 mm diameter, and other properties, number of side and 2, as you can see, right? And edge distance 30. So it will be applicable 30 mm distance from this, right? So if you go into the 3D view, as you can see, the proper bolting is now applicable at here. Good. Similarly, select the bolt and do the mirror on the opposite side. So selecting the bolt, going to the side plan view, double M, and now we will do the mirror on the opposite side. It will be automatically picked up all the things. Good. Now this is very most important. After we modeling plate, bolt, applying the weld, now we want to create this connection as our custom connection, right? And we want to apply this connection at each and every apex location. So at this location, this location, this location, and this location. So how to create the custom connection? So we will see. So use the structural connection tool. So I will be use structural connection tool. We will be select both the beam. Okay, we will be select both the beam and press enter. So by default it will be used as a generic connection. So by default it will be used as a generic connection, and we will be click on customize, and we will be give the name custom apex, or we can say modified apex connection, right? So we can use modified apex connection and press click on OK. Now it is asking about selecting the member. So here by default it will be say add to the selection, and obviously we will use this, and we will use click and drag by selecting all of this. So here it's include everything. Here it is include shorten modifier, plates, bolts, welds, everything. As you can see, left to right, all the selection we need to cover up, and we will be use the finish tool. We will click on finish. So here you can see, if I'm now clicking here, modified apex connection is now available. Now this connection we want to applicable at here. So apply this connection to all apex point by using the connection tool, right? So what you can do, you can use connection, selecting this member, control, selecting this member, and press the enter. As you can see, by default it is generic apex generic connection, and we will just type modified apex connection. As you can see, connection is automatically applicable at here. Now repeat the same procedure at here. So selecting this, press enter. Then after modified, similarly repeat the procedure for this two as well.